Okay, here we have an example of a grouped frequency table. In this case it's continuous data, but it doesn't have to be. Continuous data, when I say that I mean length. Length is something that you can measure to any degree of accuracy. The lengths of 30 12-day-old babies were measured. The data was collected and is represented using the group frequency table shown below. We need to estimate the mean length and the mean standard deviation of lengths. So the key word there is estimate. It doesn't mean sort of guess something using your best knowledge or your informed position or something like that. It means that all we can do is estimate, because we don't actually know how long these babies are. That first group of babies, for example, it just says they're greater than or equal to 40 centimeters, but less than 42. So we don't know that they could all be 40 centimeters, they could all be just under 42, or they could all be bang in the middle of 41. We have no idea. I'm sure you've seen group data before in the IGCSE. The best thing you can do, or really the only thing that seems to be sensible, is to assume that they're all in the middle. So what you do, for that first group of babies, you assume they're all 41 centimeters. For the second group, you assume they're all 43, and so on. So the only difference between a grouped frequency table and a frequency table with regard to calculating means and standard deviations, you use, for your x values, you just use midpoints. So I have already put in list 1 and list 2 into the calculators, so let's have a look. So on the TI, if we go to Stat and Edit, you can see I've got the midpoint. So the midpoint of 40 and 42 is 41. The midpoint of 42 and 44 is 43, and so on. I've got the frequencies over here as well. If I just look on the Casio, menu statistics, we've got the same list 1, list 2. So the list 1 is the midpoint of the lengths, and list 2 is the frequency. You've got that one baby that was between 40 and 42 centimeters, another one baby that was between 42 and 44. We'd assume that baby is 43 centimeters long, and so on. Right, so once you've done that, you just need to use the features just the same. So tell the thing it's a frequency table, go into stat mode, and it'll just calculate for you. So stat and calc, one var stats, we've only got one variable, that's length of baby. So one variable, and you need to tell it it's a frequency table. Now, because I've just been working with a frequency table, this is actually the right settings. So list 1 was the list for the variable, list 2 was the frequency list, so as in the frequencies of list 1, so that's fine. I'm going to calculate that. Let's just catch up on the TI. If we go to calc and set, and again, because I've just done a frequency table calculation on here, it's fine. List 1, list 2 is your basic frequency table setup. If it was a list of numbers, it would say list 1, 1. So that's fine too. So I'm going to go 1 var, and on the TI you just click through everything. I'm interested in X bar, and I'm interested in this sigma X. So my estimate mean length, I'm going to call it mu, but on the calculator it's this X bar, like that. So mu is to 3 significant figures, 48.3, and the units are centimeters. Sigma it's written as sigma X in here. You can see on both calculators it's 2.66. 2.66, again it's centimeters. And that's it really. I'm not going to show you how to do it longhand, but I'll just talk you. All you would do, you would just change your x values to midpoints. Everything else, then you'd potentially, if you were doing a mean of the squared deviations, you would work out your mean estimate, and using midpoints again, you would do your x minus x bar, your x minus x bar squared, your fx minus x bar squared, work out the mean of them, square root it. That's all you would do. So I'm not going to do it here, but the only difference between a frequency table and a group frequency table is midpoints. And if it is discrete data, so as in you don't need the inequalities, you could group it a different way, like shoe size, something like that. You'd still use midpoints the same. Final point, if you're not 100% sure on what the midpoint is between two numbers, just add them up and divide by 2. These particular ones are really easy, but they won't always be really easy. So it's not worth getting it wrong just by guessing. Just add them up and divide by 2.